Hi, everyone. Welcome to the Lightning Talks. Don't tell the other sessions. This is my favorite session. I really love the back-to-back presentation of a bunch of information all at once. Hopefully you do too. There's going to be a lot of really interesting research talks that we're going to hear about. Each presenter has about 3 minutes to give their talk in, and then all the talks are going to happen in the first half hour, and then we'll have a discussion time. So follow up with those presenters in that discussion time. You can get coffee outside. I'll mention that again when we get to the end of the presenters list. They're going to go back to back, and I'm not going to introduce them mostly, but Mariah is going to start us off. And so welcome to the Lightning Talk session.
What's up? How's it going? Let's see. Where is advanced? Okay. What's it mean to be a good AI developer? Or, okay, imagine we're all in a car together and we're headed towards wherever the real future of AI is going to be. Who's driving? Or, okay, I like this question too. Imagine a student so worried about that future that they say in that like half joking kind of way, I'm just going to like put my head down and be a cog in the machine, or I'm just going to do whatever the algorithm says or whatever my boss tells me to do, or I'm just going to go do evil for money. What would you say to someone feeling like that? I opened with these because these are the kinds of questions I actually ask people in my dissertation, Doing Evil for Money. Hi, I'm Mariah Knowles, she, her, hers. I have a background in computer science and teaching AI ethics. And that experience left me with some lingering questions about the moral pressures that we're facing in our practice today. For example, in order to be effective, advice practice must appeal to practitioners' real internal motivations and our experiences. So someone should go talk to practitioners, and that's what I did. So between 2020 and 2025, a lot of things happened in the world in that time. As I was just talking to Abe about, I constantly had to adjust. But I talked over 4 rounds of interviews with a total of 10 teachers and 10 practitioners working in AI ethics for a total of 28 interviews. And I'm here today, come talk to me about my 3 key themes that I will give a little intro about. So in short, there's this really strong sense of responsibility that we use in our practice to unpack other things. Even though a lot of kind of guidelines from AI ethics don't start from that point of view, when I talk to people, that's kind of where they always go back and ground to. There's how when we're making sense of moral expectations in AI, we have to do it together as a collective. Yet at the same time, we have these tendencies of treating people badly at the boundaries of our practice, who help us sift through and translate moral expectations, pressures, policy messages, and so on into action that we can take. There's also this really complicated sense of belonging and inclusion, that these are just the best words that I have found to describe the vague thing that we seem to be getting at, that we haven't fully unpacked in our practice yet. But some things in it that I've seen when speaking with people is, one, we have to respect the way that we're all complex persons. We need to resist this tendency in tech to narrow the way that we think about what a life experience is. We have to uproot these deeply held these deeply held notions that there's only one like right career trajectory. Every single person I spoke to in those 20 people compared themselves against the right trajectory that they didn't have, and yet not a single one of them had it, except for one who said she was going to be a lawyer when she was 7, and then she did it. And we have to kind of incorporate this thinking into our everyday practical wisdom. So if you want to do evil for money, come talk to me. I'll also be at the poster session. Thank you.
Hello, everyone. I'm Kiki from the civil engineering. So today I'll talk about the key challenge in the autonomous driving and how to solve it with the help of large language models. So one key challenge in autonomous driving is that we sometimes meet some really dangerous and rare scenarios. So in these scenarios, they are called corner case because it's so hard for us to collect the data and train the current AI models to help with them. So that's why we start thinking, how about using the large language models to help us deal with these corner cases? So the large language models, they are good in reasoning. They can understand the scenario and think like the human drivers and then make the driving decisions. But there's also some problem. The large language models, they are not stable enough. Sometimes they make things up. They may misunderstand the scenario and make some unsafe decisions. So given this problem, we are thinking about how to solve this. Our idea is to combine the large language model with some domain knowledge. In transportation engineering, we already have some well-tested control methods. These methods, they have followed the fundamental principles in driving, and they have high interpretability. But these methods are not adaptive enough to different scenarios. So our idea is to combine them together. We design a two-layer method that is on the top, the large language model or the vision language model. They make the high-level decision-making. They are given the scenario captured by the vehicle camera and some information collected about the driving scenario, and then make some decisions about the best parameter we use in current situations of driving. And then the lower level, the MPC controller is a widely applied vehicle control model in autonomous driving. They could help handle the safer and smoother driving in all the driving scenarios. So this is how we combine them together. And this design also solves another problem. We know the large language model, they usually need time to think and need time to make the decision. But the autonomous driving needs really faster control. So this structure could separate them together. The upper level large language model only updates when needed. And the MPC controller keeps control of the vehicle in really fast speed. So this is our approach to connect the best parts of both large language model and MPC controller. Large language model help reasoning, and MPC helps the stable control. We believe this kind of combination could also be applied in other engineering tasks, like the robots and drones. And in the future, before the large language model are powerful enough to handle everything, we still believe that this kind of combination of large language model and domain knowledge is the best way to unlock the potential of large language model in handling the engineering tasks. That's all for my presentation. Thank you.
Hello, my name is Maria Oros. I'm a data scientist at the Data Science Institute, and today I want to talk to you about our open source crop disease forecasting tool. So what is the challenge that we are facing? Emerging diseases pose a growing threat to crop yields. In particular, and as an example, in the right side, I'm showing the disease impact ranking in soybean in 2024, sourced from the Crop Protection Network, where in soybean, we have faced a lot of challenges by the white mold disease. This situation creates a unique opportunity to support adaptation of agricultural practices using AI and machine learning solutions that are accessible to agricultural practitioners. So in our approach, we have developed an open source platform and an API for daily crop disease forecasting for soybean and also for corn. In the right side, I am showing how our app looks like, where we are showcasing for each Mesonet weather station how the white mold disease looks like in terms of the risk of having this disease for this location, and for any selecting forecasting date. There are two options to choose the location. One is the option to choose the Mesonet weather station, but also there is a custom option to pin your own location within Wisconsin and showing the trend of the diseases for corn and for soybean. Our app shows not only this dynamic map, but also a summary of the trends on weather and risk for the given forecasting date. It allows you also to download reports to showcase and to summarize the risk that you are choosing by this forecasting date and disease. In summary, our app offers a custom application with dynamic maps and weather trends visualization. It also enables a seamless integration with existing systems via API. Our code is open, is available under MIT license. This is how our API is up and running. This is how it looks like. And it provides the forecasting for the 6 diseases, 3 for corn, 3 for soybean, the most common diseases in those crops, for any given forecasting date, for any number of days, and for any weather WISConnect station. So in summary, there is a barrier of complexity of models that we can deliver to the masses. This code and tool help remove this barrier. They allow us to use very complex models, including advanced machine learning, to improve accuracy while keeping the usability and availability possible for the agricultural masses. This is my team. We are collaborating with Damon Smith Lab, with the WISConnect team, with the Open Source Program Office, and the Data Science Institute to discuss ideas on how to leverage this solution on crop disease forecasting. Feel free to reach out with us, and thank you very much.
Hi, everybody. I'm Nick Coiler, manager of the Statistical Consulting Group on campus, and I'm here to talk a little bit about how our group can improve your research. So who are we? We're a collection of staff and graduate students in the statistics department with expertise in supporting quantitative research. We can assist with all aspects of the research process, from grant writing to addressing reviewer comments and everything in between. We work collaboratively, aiming to teach you what you need to do, not do it for you. We work via fee agreements. Interested parties draft a contract with us, then we invoice at an hourly rate at the end of the agreement period. We currently have agreements with several schools, departments, and labs on campus, but are open to working with anyone, including people that are not part of UW. More on how you can collaborate with us will be shared at the end of the presentation. So I just want to give a couple examples of what we've done in the past. Professor in the Animal and Dairy Sciences department wanted to compare 2 different methods for evaluating glucose levels in feedstuffs. She showed me a linear regression analysis with an R-squared of 0.9997. Great fit, right? Well, turns out we looked at the residuals and the relationship was not linear, but in fact quadratic. So even with the very high R-squared, it wasn't predicting as well as it could have. Up until our collaboration, everyone in her discipline assumed a linear relationship, but fitting that quadratic improved the predictive ability immensely. So you don't know what you don't know, and our expertise can make the difference. A professor in the School of Veterinary Medicine, in collaboration with Milwaukee County Zoo, sought a way to determine the sex of Humboldt penguins without a costly blood test. Using data on a wild population of penguins, we built a logistic regression model using length and width of beak and length of wing as predictors, and we were able to predict the sex in 87.7% of cases. So here's just some things that people we've worked with in the past have said about us. Statistical Consulting Group has been critical to the success of my laboratory's research. Their friendliness, skills, expertise, and total professionalism have enabled many of our papers, including high-impact papers showcasing the best of the Wisconsin idea. That's from a professor in botany. Staff member in plant pathology says, with the help of the Statistical Consulting Group, I was able to achieve more with my data than I could have on my own. A PhD student in bacteriology says statistical consultations ensure that our research gets reviewed by a statistician before publication, which is crucial for maintaining the quality of our work. And finally, a master's student in soil science says the knowledge I have gained in 1 hour of working with them is equivalent to months of a high-level statistics course. This is an invaluable resource. So if you're interested in collaborating with us, let's talk. For more information or discuss a possible agreement, you can email statconsulting@stat.wisc.edu or go to stat.wisc.edu/statistical-consulting. I'll also be around after the session if you want to talk to me about anything. Thank you very much.
Hello, everyone. My name is Kainan, postdoctoral data scientist here. And I'd like to start this presentation discussing 3 possible scenarios. So the first scenario, we have Matt, a data engineer who needs to update the database schema for the next release, but which tables and columns can he safely update without breaking downstream pipelines? The second scenario, we have Alex, who is a business intelligence analyst And she realized that her dashboard is slowing down as database grows. How can she pinpoint which tables are overused? Which columns can she is truly essential for reports? And finally, I have Maria, a data scientist who just joined the team. And she's facing reports with lots of SQL files without proper documentation, with a database of over 300 tables, and how she should even begin start working with it. So we have a common challenge here that's understanding the database dependencies, which is a manual process, error-prone, and time-consuming. So what if we had an intelligent, fast, and automatic way to list database dependencies? That's why we have developed SQL Apps, a Python open source package for leverage the contextual power of large language models to extract database dependencies, meaning tables and columns that must exist before the query execution, and also outputs, the tables and columns that are generated or modified by the script. All of that while ignoring temporary artifacts like common table expressions, temporary tables, and so on. Here we can see the model in action. So in the left panel, we have SQL file example, where you can see the table dependencies in red, some table outputs in yellow, a table that's both a dependency and output in purple, and temporary tables in gray that should be ignored in the final result. So in the right panel, we see the output of the model who correctly identified all tables and columns it's supposed to identify, and have also tested a lot of annotated examples, varying the complexity, and the model is working quite good. So this slide shows some key features of the model. All of these present in the documentation, so I'm linking it in the final slide, so you can take a look at it. So let's jump to the next one, where I show you real-world use case for the package. So we have applied for a particular project, and we are able to identify the most common tables and columns, the relationship between them, and even columns that they didn't even know was important for this project. That's it. This is available online. You can try it yourself. Let us know about your experiences. And yeah, thank you so much.
Hello, my name is Adam Huffman, and we had a conundrum of how to evaluate open-ended comments from over 400 course sections every semester. And so to tackle that, we looked at using BigQuery's AutoML, enabling us to query a model, in our case, Gemini, in a SQL-like structure, where then we were able to ask Gemini to help us pull out themes directly from the course comments, and then provide them in a reporting solution where you can search by the course section to get the themes that were brought about from the open-ended course comments from those students.
We're a tag team, obviously. I'm Ron Kramer, Director of Teaching and Learning at the School of Business. So how did we use this information to the improvement of teaching? We take the thematic analysis, we pair it with the quantitative scores. That gives us the start of the story, but it's a much more holistic approach that we take with this. Perhaps it involves looking in on Canvas courses to see how instructors have things organized. What tools are they using? Is it easy for students to navigate through? We talk with our partners in the school, academic advising, success coaching, people in the program offices who can tell us what students are saying about particular courses, programs, or instructors. Obviously, we have discussions with department chairs. What are their concerns as it relates to their area? The people who are teaching their courses, we want to know like what is rising to the top for them by way of teaching topics as well. We always, our main business is consultations with instructors. We're always meeting with instructors to talk about, what did you learn from your course evaluations? What resonates with you? What areas might we assist you with? And that may lead to a potential classroom observation where we come in, we have our own framework that we talk through with the instructor, and then we can have some comments and feedback on their methodology. What does it all add up to? Well, we're able to identify and elevate teaching topics and then develop programming for those topics, workshops, webinars, online resources. We're also able then to identify faculty champions, people who are doing a particularly good job with, say, student engagement or feedback or authentic assessments. And we can have them help lead the conversation in communities of practice within the School of Business and help to kind of move forward with that conversation. all in all, this helps us to reinforce the set and actually get people more interested and excited in getting good response rates, because that is one of our biggest challenges is at the end of the semester, oh yeah, I got to do that course evaluation. Actually, over time, we have found now that because they see what we do with that information, they are much more encouraged to have students complete those course evaluations and provide that critical student feedback that we can use. Thank you.
Good morning, everyone, and thank you for your time. I am Justin Anderson, a senior intellectual property manager and IP attorney at the Wisconsin Alumni Research Foundation, or WARF. We're currently celebrating our 100th anniversary, making us the nation's oldest technology transfer office. As a separate nonprofit supporting entity, our mission is to support the research that goes on here at UW-Madison and the Mortgage Institute. Today, I'm going to highlight how you as researchers can make the most of data licensing opportunities. So academic research, as you know, is a systematic process of inquiry that aims to create new knowledge, test theories, and contribute to academic discourse, often involving the collection, analysis, and interpretation of data. In conducting your research and answering fundamental questions, you carry out experiments, thereby generating results and valuable data that could be suitable for technology transfer. So what is technology transfer, and how does it apply to you? Well, the results of your research could be eligible for statutory IP protection, which could then be licensed or transferred to third parties. Under an appropriate license, companies can develop innovative and life-improving technologies, including products and services. Here are some examples of statutory and other IP. And while raw data doesn't necessarily qualify for statutory protection, if applied or curated, it might. And further, even without IP per se, it can be monetized via licensing. So why is licensing beneficial? Well, in short, it is key in the cycle of innovation that's pictured here, generating revenue that is shared directly with you as creators and inventors, as well as the university and across campus writ large. Said differently, these returns can be used to support further research and projects in your lab, department, or college. Not only that, it can also broaden the impact of your research. So here are some questions you might have about moving your research beyond academia. Are commercial entities already interested in your research? Have they expressed interest in your data, your trained models, your results? If not, should commercial entities be interested in your research? And maybe WARF can help market that technology and make it known. What are the best ways to move these results out into the market? Perhaps it's through an open source license, perhaps it's a dual licensing strategy where we have a commercial license as well. And at the end here, can the innovation itself actually be licensed? Are there restrictions or obligations that could impede the transfer to third parties? WARF's team of professionals, including myself, can happily answer these questions, and I'd be happy to work with you to identify a path forward. Thanks for your time, and I'll be around if you have any questions.
Hey everyone, my name is Ryan Yee, and I will be sharing a new method for modeling smooth data. So to illustrate our new method, I am going to go through an example of estimating field goal percentage in the NBA. In layman's terms, field goal percentage is basically the probability that a player will make the next shot that they take. And so to estimate this quantity, we can use data provided by the NBA, which includes the location, player, and result of every shot taken during the season. So up on the screen, I have an example of this data plotted for 2 different players that you might recognize. And basically my goal is to estimate a function that will return the probability that the player will make their next shot, analogously field goal percentage. And this is maybe a kind of a lofty goal, but it's the basic problem statement of a regression problem. So we can use, typical regression techniques to solve this. A natural sort of solution might be to use a regression tree method. Regression trees are really good at modeling linear data and doesn't require much pre-processing to get started. However, when we use like a typical regression tree method on this problem, we get some sort of puzzling results. For instance, if I can draw your attention to the graph on the right near the free throw line, the field goal percentage we estimate for this player goes from like well below 50% up to well above 50% and then back below well 50%, all within like a very short range. And the reason we get this behavior is because regression trees typically output constants in their leaf nodes, which corresponds to us approximating the target function with a step function. And step functions just don't really respect the fidelity of the problem that we're working with in this instance. And so what we did is we modified the regression trees to output smooth functions in the leaf nodes. We achieved this smoothness by replacing this constant output with the output from a single layer neural net. And we find that when we apply that to this problem, we improve the predictive results significantly. And we also just get much more intuitive sort of results visually. And so the key takeaway I'm hoping that you take from this is that RidgeBart, which is what we call our new method, is really good at targeted smoothing problems. Targeted smoothing problems are problems where one or more of the covariates you're interested in are smooth with respect to the response. So some examples are injury recovery, disease risk, pollutant profiles, treatment effects, estimating these things. We are working with people working on some of these problems. And yeah, so if you found any of this interesting, we have a paper out that goes more in depth into the computational efficiency of our algorithm and also some theoretical guarantees about the results. And the last thing I'll say is if you're working on a targeted smoothing problem and you'd like to get help set up using RidgeBart, please feel free to reach out and we'd be happy to help.
Hello, everybody. My name is Izzy. I'm a recent UW grad, and I'm currently a web developer with Wisconet. How many of you have heard of Wisconet? Can you raise your hands? All right, great. So Wisconet is the Wisconsin Environmental Mesonet. So a mesonet is a network of weather stations, and currently Wisconet has 58 throughout the state of Wisconsin. So you can see on that map the location of all of our stations, and we're hoping to have 80 by the end of the summer, which is very exciting. So these mesonet stations collect data every 5 minutes. So there's also a photo of one of our mesonet stations. That is the Verona mesonet station, so very nearby. And these mesonet stations collect data on air temperature, relative humidity, wind speed, wind gust, wind direction, solar radiation, barometric pressure, total precipitation, soil temperature and moisture, leaf wetness, and canopy wetness. Additionally, our backend does calculations to get the hourly and daily minimum, maximum, and averages based on these 5-minute measures. So, for example, the daily maximum temperature. Here's a little overview of our data flow. So the Wisconet stations send data packets every 5 minutes to our cloud. We use Network Manager 10 and the campus cloud infrastructure. Then an ingester server sends that data to our backend, which is hosted by Amazon Web Services. Then using an API call, we present this information on our website. Our API is publicly accessible, so anybody can also access our data. So to speak a little more on our API, an API is an application programming interface for those who are unfamiliar. It's essentially a URL you can use to request data from us. So here are a few useful API calls. We have wisconet.wisc.edu/API/v1/stations, and that will give you the metadata on all of our stations. So station ID, latitude and longitude, city, and other fields like that. We also have a fields API call, which will give you metadata on all of our fields. So if you want to see a list of what fields we take measurements on, you can access that there. That will also provide you the units and the collection frequency. We have an API call to get you the latest measures, and you need to input a station ID for that, which you would get from that first API call. And then we also have a measures by day API call, which takes fields as inputs, and you would use the standard names of the fields that you get from the fields API call and a date. And that would return every station's data for a specific field on a specific date. And so right there is an example API call giving you the most recent data on our Verona station. So OJNR is that station ID for Verona. This is an example. And currently the National Weather Service, the United States Department of Agriculture, and the National Mesonet Program all use our API for our services, which is super exciting. And we hope that more data science researchers also start using our API. We think that as the data science community increasingly integrates AI and machine learning into their research, that our data could be extremely helpful for addressing challenges relating to weather forecasting, agriculture, and beyond. You can contact us at wisconet@cals.wisc.edu and check out our website. We're also redoing our website later this spring, which is super exciting, so stay tuned for that. And if anybody has any more questions, feel free to talk to me afterwards. Thank you.
Hi, everybody. I'm Johnny Ullman. I'm a newly hired assistant professor in School of Mass Public Health in the WARF and Department of Population Health Sciences. It is wonderful to be here and to have this event. These talks are awesome. And Izzy, that last one, definitely going to use that for an upcoming project. I'm going to talk about, the title is longer than I probably should have had, but I'm going to be discussing this dashboard. It's called the Global Mosquito Observation Dashboard. And I have a quick QR code here, but I'll go through some of the features and what we intend to do with it that ties into the data science component. So this was something that was developed when I was a postdoc at University of South Florida a few years ago. And I took this from the ground up, trained it, and then launched it. And it's been getting quite a lot of attention. And with this wealth of information, the whole point of this is to make this high quality, equitable data source for anyone in the world that has access to the internet, which in and of itself is also sort of a privilege. So we're trying to be mindful of that as well. But this is I had a nice video kind of going through some of the features, but I'll do this kind of like image stills. But this is what the dashboard looks like. And what this does is it pulls the API sources from 4 different feeds from citizen science apps. So I don't know if you can see them on the bottom, but there's one of the main apps we use is iNaturalist, which I use frequently, Mosquito Alert, which is very popular in Europe. And then NASA has Globe, which has Mosquito Habitat Mapper and Land Cover. These on a daily basis pull anywhere between 500 and 5,000 mosquito observations that we have tailored on the back end that come in, and then they auto-populate. So all of these little points are individual submissions. You can click on any one. All this information is free to use as well. So the top kind of filters, you can look at specific space by time, by species, and also additional features, some of which we are trying to incorporate with the medical aspects. So what are potential medically important species, what might have been not detected there in some time or are new, so re-emerging, emerging, invasive species, et cetera. And then I wanted to kind of just use this one example here. So imagine this, if you click, it will automatically zoom into this point. And this is a specific point in Honduras. This is an Aedes scapularis mosquito. It's a kind of a really pretty mosquito, but you can click on that image and then that image will actually pop up and you can, hopefully, this is what we're trying to build with Data Science Institute and others. We're trying to do this mass-based neural networking, convolutional neural net, where we can look at each individual morphological piece, come up with a real-time estimate, and then put all that together to be like, what is this likelihood of this species? So this is hopefully, we're trying to make this all integrated. There's a lot of challenges and missteps, but we are currently working on that. And I was hoping to have some more results, but it's looking good. We're starting slow. And then I have some pictures of some students here who are in the medical entomology lab on campus, where we're taking sort of control images of insectary reared mosquitoes to get to further train that model. Thank you.
Hi, everyone. So I'm going to talk about a study that we finished up data collection about a year ago. And this is in collaboration with Brooke Ammerman, who's over in psychology, whereas I'm in the Center for Healthy Minds. Our goal is really trying to model momentary suicide risk. And to do this, we collected screenshots from participants' smartphones. So every 5 seconds that their phone was in use, we collected a screenshot. This got uploaded to our servers. We captured this data alongside active data collection. So we had momentary assessments asking self-report from these individuals about 6 times a day, mostly focusing on active suicidal ideation, passive suicidal ideation, and questions about suicidal planning. So here are some of the primary things that we learned in this. So leading up to asking these people questions about suicide risk, when individuals responded positively, so non-zero, active, passive, suicidal ideation or suicidal planning, we found that they tended to use their phones
to a greater extent leading up to that EMA assessment, and then in the hours following that EMA assessment. We're not here making a statement about phone use link is causing the increase in suicidal ideation, just noting kind of the corollary or correlation between these two things. The other thing that we've focused on is trying to identify is phone use in the evening and specifically related to sleep, is this bad? And at least in our data, it's a somewhat complicated story. It's particularly complicated if you just look at phone use during times in which individuals reported that they were sleeping. So we asked them in the morning, when did you go to bed? When did you wake up? We took those windows. Were there any screenshots in these windows? Essentially inconclusive in our very recent results. But the one thing that we found was that when we coded for keyboard use, so we just applied a relatively simple model to determine whether there's a keyboard present in that screenshot. When individuals were using a keyboard, thus we think that they're engaging in some form of active messaging or social interaction, that individuals reported lower suicide risk the following day. So we see somewhat of a protective factor for this. Finally, currently we're working on trying to get more nuanced data kind of extracted from these screenshots. We're specifically focusing on social interactions. So what social media platform are they using? And then if they're using that platform, can we determine essentially what text is essentially attributed to the user or the person using the phone, and what text are they viewing either passively or actively? We can think of an SMS text message back and forth. We're currently applying some vision language models to extract this from each screenshot. With the goal of, in the next couple of months, we're building a real-time assessment instrument where we essentially process these screenshots in relatively real time, determine suicide risk, and then this will essentially allow us to then ping them with micro interventions or any type of safety planning if we deem suicide risk to be high at this time. Thank you.
Hello, my name is Abe. I work at the Data Science Institute, and I'd like to talk to you today about cloud platforms and how you can also build your own. I think these platforms are really great because you can connect with other people, you can collaborate, and you can share all sorts of data and ideas. Here are a couple examples of platforms that we built for UW projects, just to illustrate. The first is we built a platform for the Sound Forest Lab to share audio data from rainforests around the world. The second one is a platform called Dream Machines that we built to generate AI images, and it was used in the prompt battle last fall that was created by DSI and WARF. We built a virtual optics simulator, which is being used by Professor Yeselkoy in her optics lab. And we built a platform with the campus cyber infrastructure group to interface with S3 buckets. So why might you want to deploy one of these platforms? The first is data sovereignty. If you build your own platform, you're lessening your dependence on the tech giants. Next, user experience. If you have one platform that has like data sharing and messaging and everything all integrated, you can provide a better user experience. And then last, I think it's just really cool. You're not just building software, you can actually build communities. So if these are so great, why are people not building them? Well, it's tough. There's a lot of infrastructure that you have to build. And the conventional approach of building web applications relies on all these low-level tools, got frameworks and libraries and package managers, all these things. So it's too difficult and it takes too long. It can take months or years to build these. So we need a better way. Okay, so what if we built cloud platforms the same way that we build desktop apps? So when you build a desktop app, you don't start with a blank slate. You start with an operating system. An operating system gives you like a file system, gives you window management, all these sorts of things. And then on top of that, we can have a library of existing apps for kind of the common tasks like chat and image viewing, all these kind of base level things. By doing this, you can put your energy into the custom apps that make your platform unique. So over the past couple of years, we've been building a cloud OS that we call Sheradigm, and it's open source. It's MIT licensed. We also have an app store with about 40 different apps that you can install in your platform or uninstall very easily. If you don't want to build your own platform, but you just want to deploy one, we also have a set of pre-made platforms. They have a Docker installation, so you basically just apply your own branding and you can run it. So if you have ideas for building your own data platform, come and talk to us. We're glad to help.
Hi, everyone. I'm Aditya Kumar from the Space Science and Engineering Center. I'm an assistant researcher there. We are working on forecasting the fire additive power using machine learning. I would like to acknowledge the contributions of all the team members for this project. So the problem statement we are focusing on is prediction of fire intensification in the next 6 hours post an observation. We are using the changes in fire energy rate as our primary indicator. So when fires start, they undergo various phases, which includes intensification and declination. So we are using the FRP is the major indicator of these phases. So we are using the FRP here, and the metric we are focusing on is the max FRP and the current FRP ratio. The max FRP is defined as the maximum observed value in the next 6 hours, and if this value exceeds 1, it's an intensification phase, and less than 1 would be a declination phase. So the machine learning algorithms we are focusing on are primarily decision tree-based algorithms. The specific algorithm we are using is the random forest regression. Our goal is to capture relationships between the FRP changes and the major factors that affect these phases. For example, the FRP changes are dependent on the meteorology and the biomass available. So currently in the version 1 of this model, we are only focusing on changes in meteorology. The training data we are using is from a newly developed next generation fire system, which is being developed at UW-Madison at the SIMS and SSEC. This includes project leadership from Brad Pierce, the director of SSEC, Michael Pavlon is from NOAA, and Jason Otkin from SIMS. This is a system which provides high resolution fire observations, and which is ideally suited to this kind of work. It utilizes geostationary data from the GOES satellites, and we are using meteorology output from a weather forecasting model that's also from NOAA. For the training data, we used 1 year of fire season data from NGFS. The model results are shown here. The model evaluation was carried out using 2024 fire season, and as you can see, we predicted the ratio pretty well, except for cases where the fire intensifies significantly. That's the case we need to improve upon. And in the second figure, you can see a time series of a particular fire from Idaho, sorry. And the phase highlighted here is the intensification phase. The black circles represent the observed values, and the red circle represent the predicted values. So as you can see, we are underestimating, but still doing a reasonable job. The expected impacts of this research are in the real world application. It's primarily to assist in decision making, to know well in advance whether a fire is intensifying or not, and to plan the use of resources in a better way. In the research world, we are interested in what are the major factors that affect these phases. What is the relative importance of those factors? That's all I have. Thank you.
Okay. Hello. Thank you for being here. My name is Agustin Chasco, and I work in the Department of Animal and Dairy Science here in UW-Madison. So today we are going to talk about dairy, the dairy industry. Dairy industry, what it does, it produces milk. And for produce milk, a cow has to have a baby. So for having a baby, the cow has to be pregnant. So pregnancy in dairy industry is a key factor that predicts the profitability and the sustainability of the industry. Nowadays, these animals, they have a problem. They have a really high production level, but they are really, really bad for getting pregnant. They have low pregnancy rate. So I am working in breeding and genetics, and my work is to improve the population of dairy cattle, Holstein, for higher reproductive performance. We are working with these sensors. These sensors, they monitor the activity and the rumination of the animal. This is information from a single animal. The green data points is the raw activity in the top and raw rumination in the middle. And the purple data points is how we smooth the data. So what we did basically, we developed a script, but that is able to identify when the animal has an acute increase in activity, as you can see, and a decrease in rumination, because we know that this moment is associated with the moment when the animal is ovulating and showing estrus. This is called like estrus behavior. So once we can identify this behavioral change, the most important, because we want to select for higher behavioral change, is validate these changes with the probability of pregnancy success. So basically here in the x-axis, you have the magnitude of the change, and in the y-axis, you have the probability of pregnancy success. And we are accounting for other predictors for make sure that these vectors that indicate the magnitude of the change are really associated with higher fertility. So the most important question that we want to answer, and we did, is showing this plot, is how much of this variability in the characteristics of estrus behavior is linked to the genome. Because suppose that is 100% dependent of the genome, that means that we can easily select a subpopulation that has higher expression and then has higher fertility. If it's 0%, this is not an option. So here in the y-axis, in the x-axis, you see time. In the y-axis, you see what is called heritability, and the heritability is 20% at the beginning. So 20% of this variation is accounted by the genome. The vertical lines are the 95% confidence interval. We do this with a sliding window technique. So this is the short history of what we do. We try to connect what is going on in the farm, these streams of data, and we try to increase the value of this data using diverse AI tools, logistic regression, mixed models, etc. Thank you for everything.
Hi, everyone. My name is Christina Cook from the Center for High Throughput Computing. And we'll start with a little question for the audience. Who has heard of ChatGPT? Who has heard of DeepSeek? Same hands. Okay. So guessing most people here have heard of these things and that they are examples of machine learning models. So sets of equations and values that can be used to make statistical predictions. And more, as you've just heard, researchers like yourselves are using these models as part of their research work. So I'm here partially because running these models requires computers. Sometimes it requires a lot of computing power. And so I want to share 3 ways that our center, CHTC, can help people who want to scale out their machine learning models in a big way, access to computational power, support, and sort of exploration and innovation in this space. So first, we have computational power in the form of especially GPUs. They're, for those who don't know, specialized computing units that are really well suited to running machine learning model computations. And so we have at the moment at CHTC around 200 different kinds of GPUs. They're part of our larger computational system and available to any research group on campus that wants to use them. You can just sign up for an account or talk to us if this is of interest to you. So thing number 1. Thing number 2 is support. It's not easy to use these models. It's not easy to get started on large computing systems like the ones we run at CHTC. So we have a team of facilitators who are here to help you with that transition process. There's a member of our center who's been focusing on machine learning use cases specifically. We are probably not going to be able to give you detailed advice about machine learning itself. There's other groups in this room, like the Data Science Institute's Data Science Hub, communities of practice that can help you get started. But once you're ready to scale up, we're here to help you with that process. Along with that aspect of things, we as a center also do computer science research on our own. And one of the things we're exploring now is just understanding different ways that we could run machine learning models at a larger scale, whether that's in a distributed fashion, if it's running on different kinds of resources. There's a couple of different questions that we have that we're partnering with people. And if you're interested in going beyond like, I'm running a notebook on a computer, or even I'm running a model on a server, but I want to think more creatively about model distribution and training, please please talk to us. You can always email us at this address, and we will have 2 posters at the poster session about basically these 2 things. So you can come talk to me or Ian Ross if you'd like to follow up. Thank you.
Good morning, everybody. My name is Guilherme Menezes. I'm a postdoc in the Department of Animal and Dairy Science. And today we're going to present how can you use drones to estimate body weight in cattle. So as you may imagine, farmers, they have a lot of money invested in cattle. And if I was the owner of these feedlots, probably I want to check the body weight of these animals every single day. But it is not possible because we cannot bring these animals to the scale and weigh them every single day. So we need technology in this context to estimate the body weight of these animals. And this is going to help us to give an idea about the performance of the animals and also decrease the uncertainty of the business, because part of the incomes came from the performance of these animals. So we collect our data in 71 heifers in our research facility. And as you can see that pictures, we flew the drone at 20 meters of height, and we extracted several Euclidean distance and features related to the body weight. So as when you go to the doctor, for example, the doctor measures us our body shape and try to understand this relationship with our body weight. So what we want to do, we want to use these features trying to estimate body weight, because we know that some of them are very high correlated. So we train a machine learning model to estimate the body weight, and we validate our model using live and out cross validation. So as you can see here, the models, our features that we extract to use the drones can estimate quite well the amount, the body weight of the animals with R-squared of 0.88 and a root mean square error close to 12%, which means that even when you have smaller animals or older animals, the model still can capture their body weight. So in this context, drones can be useful to estimate body features related to body weight and body shape. And this in the future may help farmers to predict the body weight of the animals, use the drones, which out bring them to the scale. Thank you very much. Thank you for our research group, for our sponsors. Thank you.
Hello again. My name is Chris Sendeman, a data science facilitator in the Data Science Hub, and this morning I'll be telling you about Nexus, a new website we've been building in the ML plus X community to make it easier to share AI and ML resources and knowledge across campus. For context, ML plus X is a large multidisciplinary community that brings together researchers, students, and local companies who share an interest in using ML and AI in their work. Many of us in this community are not necessarily computer scientists or data scientists, although some are, but the majority are domain scientists who are learning how to use these methods and apply it in their work. We host a variety of different regular events, including hackathons, forums, socials, and workshops to help people learn about AI and ML. And since launching in 2021, we've grown to include almost 1,000 subscribers on our email list. So I probably don't need to tell this room, but clearly AI and ML is catching on and everyone likes it. So to help meet the scale of this demand and to keep a record of some of the knowledge gained through our community's discussions, we launched this website known as ML plus X Nexus this past summer. So Nexus is an open source website for crowdsourcing useful ML and AI resources, including open source workshops, recorded talks, documentation for widely used data sets, tools, and different AI tools. The website is actively evolving alongside our community's needs, and it's growing fast. It now has over 40 resources total. So the website is hosted on GitHub, and everyone is welcome and encouraged to contribute. I know there's a lot of AI and ML expertise and knowledge sitting right here in this room, and I would encourage you all to visit the website and post a resource, whether that's a data set you've used in your work, a GitHub library that you found useful, or just a video that you watched on YouTube that you found was helpful for your work. I encourage you to check out the website and begin sharing your knowledge. Thank you.
Hello, my name is Buji. I'm a PhD student in the computer sciences department. Have you ever noticed that, despite walking through loud construction sites or even the rain, as you may have done just to get to this building today, your brain is still able to pick out speech during conversations. This phenomena is called the cocktail party effect, and it's been well studied in the neuroscience domain. And it's particularly oriented around the brain's ability to focus on a conversation in a noisy environment. Computationally, we formulate this problem as the speech denoising task, where we present a model and we try to remove unwanted sounds while we retain the important aspects of audio, namely speech. So, inspired by the brain, deep convolutional neural networks have done well to serve to achieve a lot of the functional similarities of what the brain has achieved. But there are large inefficiencies with deep CNNs. For example, the brain operates on just a mere 20 watts of power, whereas deep convolutional neural networks on modern GPUs operate on hundreds of watts. So there's a clear power advantage to the biological implementation. So our investigation is kind of going towards the direction of modeling this functional and operational aspects of the brain. And that's where we use spiking neural networks. Specifically, we're interested in the sigma delta neuron, which emulates the sparse auditory encoding of the ascending auditory path. Now, this was a great starting point for us, but we noticed that a lot of the networks that use this type of methodology have a fundamental gap where they don't model everything about audio processing in the brain. Namely, they don't model the anatomy of your body before sound enters the brain. So the pinna is, an anatomical structure that funnels and collects sound waves before it enters the brain. And a cool thing about the pinna is that it also incorporates spatial cues to allow you to determine where the source of sound is coming from. So by adding in these pinna spatial cues to the input audio, we're able to our shallow spiking neural networks are better able to track noise and remove it, and while preserving the speech. So here I'm showing a few key results from our experiments. On the left, I show just the passive improvement that the pinna provides. And on the right, I show how this performance can be further improved when the transformed input audio is now passed to a downstream spiking neural network. Now, as you'd expect, when speech is in the front and noise is in the back, naturally you get good performance because your ears open forward. And that's reflected in both plots by the bright corners in the bottom right. What's interesting is that this pattern of poor performance emerges in the spiking neural network results located on the co-located diagonal. Now, this matches human intuition because if you think about it, when a dog barks and a toddler is speaking, they're talking from the same area, and it's very hard to distinguish these two. Now, this is pretty interesting because this result doesn't show up in the left hand where we just presented with the spatial cues, which means that our model is able to develop this, and this feature emerges to match human intuition. So in conclusion, we have these models, and we feel like they are a great starting point to create low energy models that, one, reflect human biology and maybe serve as a starting point to explain human biology in certain cognitive tasks. If anyone's interested in hearing more, please find me later on in the day. Thanks.
Hi, my name is Raven Chandler, and I am a demographer and rural sociologist with the Applied Population Lab. And broadly speaking, the Applied Population Lab works with academic and audiences and academics in general, and then community partners to help translate data into usable and accessible formats. Most of what we focus on is demographic data, socioeconomic indicators, and health data. Today, I'm going to focus on a few of the geographic or spatial dimensions of the work that we've done. And so first broad category of this work is our health geography. These are 3 different examples that we've done in the past. So in this domain, we use spatial statistical analyses, such as cluster analyses, spatial regressions, different indices of segregation. I won't go into all of those because there's 5 different of those we could talk about all day. But we use those to understand health-related phenomenon in various settings. So the first is a case of clustering of personal beliefs regarding vaccinations in the state of California. So we did that for a policy brief to inform some audiences about what was happening there. The second here is we translate health data into more digestible formats like this interactive data brief that we did of the health factors and county rankings in Wisconsin. So audiences are able to click on their locations of interest and figure out different measures. So this is air pollution and particulate matter. Those are all ranked for the 72 counties. And then also in response to the COVID pandemic, we developed teaching tools to help students explore how social distancing might affect disease spread. And so again, all of these are really with different audiences in mind. So we try to think about that when we're creating these. So another aspect of this is we build data sets for on and offline use, tools featuring a wide array of geographic indices, including data related to demographics and socioeconomic status again, and then also the built environment. The Madison Indicators project is one of that we've been working on for quite a while, and we update it every so often. And so we use different neighborhood level measures here, such as transit access, third grade reading levels, birth outcomes, police incidents, right? And to give a measure of the safety and what's happening in different neighborhoods around the city. And then also we partnered with the Department of Medicine for the Neighborhood Atlas, which is probably our most used and referenced throughout like various audiences. And it's also a neighborhood disadvantage. So it shows how health outcomes are still affected even when we control for all these other factors at the individual level. The Wisconsin Food Security Project includes data on demographics and food insecurity in the food environment. And we focus on aspects like snack retailers, food pantries, summer meal sites. So we have a lot of different projects out there and trying to help all of you folks get your information out to various audiences. So I'm happy to talk about that more with you and how we could help you. So thank you.
Hi, my name is Jess Vera. I'm a biomedical data manager at Sage BioNetworks, and I'm here today to highlight some of the ways we're leveraging AI to improve data curation and discoverability in public repositories. Now, a critical part of our mission at Sage is to get data into the hands of data scientists who are contributing to a new era of biomedical research and helping to improve patient outcomes and quality of life. But achieving this is not without its challenges. And when it comes to working with human health and biomedical data, data scientists often encounter issues with small cohort sizes, unbalanced or poor quality data sets. And so finding the right data for these kinds of tasks often becomes a needle in a haystack kind of problem. That's where we come in. We are leveraging AI to improve data discoverability and reuse of the data, of the nearly 3.5 petabytes of data in our data sharing and online collaboration platform called Synapse. How are we doing this? Late last year, or December of last year, I should say, we launched Synapse Chat. This is a large language model-based search and chat feature that's integrated into Synapse and provides researchers with accurate searches and meaningful interaction with the platform that goes beyond simple keyword matching. Specifically, Synapse Chat uses a agent-based framework that's augmented with Synapse-specific knowledge. We also recently integrated the baseline Synapse Chat agent into our Python API client, which is a way of programmatically accessing Synapse. So this allows all users of Synapse, regardless of how they're accessing the platform, to have access to this particular tool. Now, the Synapse-specific knowledge that Synapse Chat has access to comes from all of the information on the platform that's used to describe the data that's hosted there. And I'm of course talking about metadata. So metadata is what makes data findable, accessible, interoperable, and reusable. And it's a really critical component of these AI tools. Now, as a data manager, I can tell you one of the biggest challenges data contributors face is collecting and distributing metadata. So we're working at Sage to build AI agents that can assist with this process. So imagine taking your protocol, your lab notebook, maybe the manuscript that you're working on, and having an AI tool extract standardized metadata and then even curate your data with that. That's what we're aiming for here. And this will significantly reduce a lot of the time and effort needed for this really critical step. So from data curation to data discoverability and reuse, these are some of the ways we're integrating AI to accelerate discoveries and transformations in human health and medicine. Thank you.
Good morning. I'm Robert Slater with the Wisconsin Reading Center, which is part of the Department of Ophthalmology. So I'd like to talk to you this morning a little bit about our pre-screening tool. And to talk about that, we need to understand what was the problem, what motivated this. And in clinical trials, people have diabetes and they go to their optometrist. The optometrist sees it, says, oh, you're a candidate for a trial. And they send it to our reading center. That's what our reading center does. And we have specialized graders who specialize in a very specific and intense grading scale. And so it's known as this ETDRS, and the eligibility for clinical trials is based on this scale. And we're always looking for the Goldilocks candidate. You want just enough diabetes, but not too much diabetes. And it sounds very flippant, but when you're doing drug trials, they have very specific criteria. So we have to find those Goldilocks candidates. So a lot of these submissions, when they come in, they fall outside of this criteria. And the problem is grading is expensive. So the humans are still doing a fantastic job. They are the experts. But the problem is we're wasting their time with bad submissions. When you try and enroll a patient, it takes time. We've got all this imaging that you have to do. And then the graders go, oh, nope, they're not eligible. So that's a loss for the company. That's a loss for us. And so we've got to figure out how can we screen these effectively to start with. So we built a vision model to screen these applicants. And the idea was if we can screen out the bad ones ahead of time, even at a higher rate, we don't have to be perfect, but the failure rate was about 50%, which was just way too high. So if we can get that failure rate lower, we don't want to miss eligible patients. So we're very sensitive to the recall. And so it's not so much about accuracy, it's really about can we get all the eligible patients we can in. If there's ineligible, that's okay, but we want to get as many ineligible out as possible. So once we do that, we're not replacing our graders. The graders, when they do this, they train on several images. So we take 7 images of your eye. The AI, we give it 1 because that's what the doctors, when they submit. So we gave the AI a little bit different task. We asked it, can you actually go through and make this judgment based on 1 image? So it turns out, yes, we can. And the goal of kind of screening out the ineligible, and this was actually a 3-class classifier, but the idea was let's get rid of those that we know are really easy to classify, throw those out, and we got our accuracy up to around 70%. So it was a big win for us, cost savings, and very very successful. And so now we've deployed this in our database. So feel free to talk to me after this. And I think this concludes the lightning session.
Hopefully you too were inspired by lots of ideas for collaborations and new projects and resources that can be useful for you.